Hello friends, welcome to Exam Tricks. This chapter is second part of the video Solar Radiation, Heat Balance and Temperature, chapter 9 of the unit Climate. In this video, we will be talking about temperature, heating and cooling of atmosphere, the reasons responsible for variation in temperature, concepts such as heat budget and temperature inversion. In the last video, we learned that Earth receives all of its energy from the Sun. However, there is a wide variation in the insolation received. But even that, the Earth neither becomes too cold nor it becomes too warm. It maintains a balance. And for this, heating and cooling of atmosphere, certain processes are involved. These processes are conduction, convection and advection. Conduction is simply the transfer of energy when two bodies are in contact and are of unequal temperature, while convection is the transfer of energy vertically. The vertical heating of the atmosphere leads to warming of the atmosphere, and the advection is horizontal movement of air. Common winds like Lu blow under the effect of advection. Through these processes, Earth loses an amount of heat equal to that gained through insolation, and this mechanism of maintaining the same temperature by the Earth is called the heat budget or heat balance. If we assume that 100 units of energy reaches the top of the atmosphere of the Earth, then in that 14 units are absorbed directly by the atmosphere and 35 units are lost to the space through reflection. The remaining 51 units then reach the surface and are absorbed by the Earth, due to which the surface gets heated. And this heated surface of the Earth then radiates back the energy in the form of long waves, and this process is called terrestrial radiation. One thing is important, that the atmosphere does not get heated from the solar radiation because they are in the form of short wave, and atmosphere does not absorb much of short wave radiation. It gets heated from the long wave radiation radiated by the Earth's surface, and the reflected amount of radiation is called the albedo of the Earth. Of the 51 units of the terrestrial radiation, atmosphere then absorbs some unit, approximately 35 units, and then remaining 17 units escape to the space, and in this manner atmosphere receives total of 14 plus 34 is equal to 48 units, and this amount is radiated back to the space by the atmosphere. So the total loss of energy to the space thus amounts to 100 units. 35 units reflected by the atmosphere, 17 units lost as terrestrial radiation, and 48 units from the atmosphere. In this manner, no net gain or loss of energy occurs in Earth's atmosphere. Now, variation in the net heat budget at the Earth's surface. Although the Earth and its atmosphere as a whole have a radiation balance or heat balance, there are latitudinal variation in heat budget. Lower latitudes receive more energy than the higher latitude, so there is a surplus in the lower latitudes while deficit in the higher latitudes. But this imbalance is maintained by transferring of heat from the tropical to the polar areas, and this surplus energy is then distributed. Energy deficit high latitude areas. This latitudinal transfer of energy takes place through air and water circulation. Winds and ocean currents carry energy from the tropical areas to the high latitude polar and subpolar areas. Thus, an overall radiation balance is maintained for the Earth as a whole, and we already learned the processes through which transfer can take place. Now let us come to the concept of temperature and the factors controlling temperature distribution. Temperature is basically the measurement of degree of hotness or coldness of a body, and here when we refer temperature, it means the temperature of the air close to the ground. This atmosphere mostly gets heated from the terrestrial radiation, therefore the temperature varies because of the different amount of insolation received by the earth's surface, and it depends on the latitude of the place. Higher the latitude, lesser the energy is received. Altitude of the place, distance from the sea, air mass and ocean currents, these all factors control temperature distribution. In the earlier video we already saw how the places near the tropics and equator receive maximum amount of insolation, whereas poles receive the least amount of insolation. Therefore temperature also varies according to that. Altitude is the second major control of temperature of a place, and since the atmosphere gets heated through air coming in contact with the heated surface of the earth, the air closest to the surface is the warmest, and the temperature decreases with increasing height above the sea level. This is also known as lapse rate, normal lapse rate. From the sea also influence the temperature due to varying degree specific heat capacity. It means that land heats up and cools down quickly in comparison to the water body. When land gets heated, the air above it also gets heated and it then rises up. We know that warm air expands and it rises up. So the cooler air from the water body rush towards the land to fill that empty space, and this is called sea bridge. So the land comes under the moderating influence of this sea bridges. The opposite happens during the night when land gets cooled very quickly in comparison to the sea, and the opposite effect is created over the sea when the warmer air above the sea rises up and the cooler air from the land blows towards the sea. We know that this is known as land breeze. First factor is air mass and ocean currents. Air mass is just volume of air which prevails over a region for longer period of time, and because of this they attain the characteristics of that region. These air masses also affects the temperature of a place. It can be warm air mass or cold air mass. Ocean currents also influence the temperature. We know that warm ocean currents like Gulf Stream have moderating influence on the eastern coast of United States. Temperature also depends upon the nature of surface. Since all the incident energy is not absorbed by the earth's surface and a part of it is reflected back, and we know that this reflected back energy is called albedo. This albedo varies from one type of surface to the other surface. While snow reflects more than 90% of the incident insolation, the other surfaces like water bodies may have a low albedo if the sun's rays are vertical or nearly vertical, and if there are no movements in the water. Now let us understand temperature distribution. Although there are great variations in temperature distribution, we can broadly divide the globe into three broad temperature zones. First, there is torrid zone, tropical region between the Tropic of Cancer and Tropic of Capricorn, where the temperature remains high. Then the temperate zone, the region above the tropical zones, mid latitude areas where the temperature remains moderate, and then the frigid zones, the polar areas where the temperature remains very low. Temperature distribution is represented on the map with the help of isotherms. The isotherms are the lines joining places with the same temperature, and for drawing the isotherms, the observed temperatures are reduced to sea level so that the influence of altitude is corrected. Normally the isotherms run parallel to the latitudes, but we know that at any given latitude, the temperature over the landmass is higher in summer and lower in winter than the temperature over the sea, and due to the influence of land and water, the isotherm for the month of July bend northwards while moving from sea to land, and the isotherm for the month of January bend towards south moving from sea to land. Since in the northern hemisphere the ratio to the land mass to the water body is more, so there are more deflection, while in the southern hemisphere there is mostly water, there are no sharp change in temperature. Now the concept of temperature inversion. we learned that lapse rate is decrease of temperature with increase in elevation. However, at times situation gets inverted. Since atmosphere gets heated from the energy radiated by the earth's surface, so air in contact with the earth's surface also gets warm. As we go up, temperature decreases. But during cool, calm and long winter nights, earth loses of its heat and becomes cooler by the morning, and so the air in contact with it also becomes cooler than the air at the upper layer of the atmosphere. So cold air is trapped below the warm upper layer. This is called temperature inversion. It is very normal in hill areas where cooler air seeps down due to gravity and remains there with layer of warm air above it. This is called air drainage. This also protects the plants from the frost damage. During winters also, due to horizontal advection, we can see dense fog is formed. This is also the result of temperature inversion. However, it lasts for few hours until the sun comes up. It can be also dangerous for health since pollution gets trapped. So, for plants it is useful, and for human health or generally for the health of all the living being it can be dangerous. With this we are done with our chapter on solar radiation, heat balance and temperature, and in the next video I will be talking about planetary winds and the distribution of pressure. Hope it helps. Thanks for watching. Subscribe to the channel. Thank you.